Morning, folks, ladies and gentlemen. Can everybody hear me okay? Okay. Yeah, my name is Jason Martin. I'm the Technical Specification Manager at Mannok, and I'm here today to talk about the benefits of our Mannok AIRCRETE thermal block. I suppose any self-builder now, one of the first decisions early that they have to make is what form of construction am I going to build my house in, and particularly the walls. There's a range of different, I suppose, options out there. So I have to decide early on what am I going to build my walls with, and it's a very important decision because, as you can see there from the wee diagram, most heat you lose through your thermal elements is lost through the walls. Up to 35% of the heat loss from your home is lost out through your walls. So it's very, very important that you get that decision right at an early stage. And that's where the Mannok AIRCRETE block comes in. Now, if you're not familiar with the block, it's an autoclaved aerated concrete block, and it's got a unique microcellular structure, and it's filled with millions of tiny air pockets, sort of like an aero bar. And those air pockets give the block its insulation properties. It's very light, yet that doesn't compromise the compressive strength. So whilst it's very light, it's still very strong. In fact, it's the same strength as a typical dense concrete block. And we've got some samples over their stand there if you want to touch and feel the block to see what it's like. Some of the benefits, obviously, from a thermal point of view, it's exceptional. It insulates up to 10 times better than of a traditional dense block. That helps achieve NZEB and passive house standards fairly easily. It's made from up to 80% recycled material, which makes it a very sustainable building material, and it's the best performing block in Ireland for combined thermal structure and fire performance. So we're going to talk about that in a little bit more detail later on. There's a range of products in terms of strength and thermal performance. So we have the 7.5 Newton block, which is typically what your dense concrete block would be, and has a conductivity of 0.9 watts per meters Kelvin. Compare that to a dense block of 1.33. The lower the thermal conductivity, the better. So there's a huge improvement in thermal performance in that block over a traditional dense block. This block here is a 2.9 Newton block, and it is a conductivity of 0.12, and that insulates up to 10 times better than a dense concrete block. So really it's out in the zone in terms of thermal performance. One of the main benefits or uses for the AIRCRETE thermal block is for thermal bridging. You may or may not have heard tell of thermal bridging, but it's an area or a component of an object that has a poorer thermal conductivity than the surrounding materials. We're going to look at a few examples in the next slides, but it creates a path of least resistance for heat transfer. So basically, a thermal bridge is where you lose more heat through that location than the surrounding locations, and it typically occurs in the junctions in a building fabric, and that again can account to a significant amount of heat loss. In fact, it can account to up to 35% of heat loss from buildings. And the more insulation you put in your walls and floors and roofs, and the better the U value of your wall, floor and roof, the more critical thermal bridging become, because that's a easier path for the heat to get out then when you've better insulated elements. Just looking at a few examples then, if we look at this diagram here, this is a typical floor to wall junction. So we have all this insulation in our floor, and we have a cavity wall insulation. We're spending a lot of money on this insulation to insulate these elements well, but we've left a gap. There's a clear path for heat to go down through this dense concrete block where our insulation envelope is broken, and this is what we call a thermal bridge. Very easy to sort that problem out. Just simply substitute 2 dense concrete blocks with 2 Mannok AIRCRETE blocks, and believe it or not, that simple change reduces the heat loss through that junction by over 10 times. So this junction here is 10 times more thermally efficient than this junction here, and there's no issue with structural performance or anything else. Other typical junctions then, If we look then at our attic, so we have a heated bedroom below, we have a cold attic space up above, we have a loft roll in here, we put in maybe 400 mil of loft roll, we have a cavity wall insulation, but again, the insulation doesn't meet. It's broken by our dense concrete block inner leaf. So again, simply, switching 2 dense blocks with 2 AIRCRETE blocks, you prevent that cold bridge at that junction. Again, we're looking here at a roof abutment detail, so we can imagine this is a sunroom. This is our rafters and our tiles, so we can imagine that sloping off into the screen there. We have our insulation in our roof between our rafters and below our rafters. This is our outer leaf. So this outside temperature, that could be maybe -5 degrees. In here we have a temperature of 20 degrees. So you have a huge amount of heat bypassing your roof insulation there through conduction in your blocks and convection here in your cavity, and poor junction. And that's typical of what a lot of houses in Ireland are being built like today. Again, very simple fix. 2 Mannok AIRCRETE blocks at that location, and you overcome that problem. I suppose heat loss is one issue with thermal bridging. The other issue is mould growth. When you have a thermal bridge at a junction, because you have so much heat loss at that junction, the surface temperature on the inside of your wall is quite low. And condensation and mould growth occurs where you have vapour carrying air droplets, where they touch and condense on a cold surface, combined with poor ventilation. So if you have a junction here whereby you have a thermal bridge down through your floor to wall junction, your surface temperature is low, you can get this problem that we're looking at here over on the right hand side. Introducing 2 Mannok AIRCRETE blocks, like what we looked at in the previous slide, increases the surface temperature from 15.282 degrees up to 18.47 degrees. So then we have warmer surface temperature and no thermal bridge at that junction. And that's important it's obviously very unsightly, as well as that it's very unhealthy for mould growth like that. So if nothing else, only for the comfort and the health of our home, it's important to address thermal bridges. What does this look like inside? So this house builder here has seen the issues with thermal bridging, and he's introduced AIRCRETE blocks in locations where he has thermal bridging. Here's the floor to wall junction. This is some of the roof abutment details here. This is probably a sunroom detail. And the thermal bridge over on the right hand, or the thermal image over on the right hand side, you can clearly see where the thermal blocks are in the wall and the purpose that they serve. And you can actually pick out the mortar joints in the blocks where you get more heat through the mortar than you are through the dense block. Probably in any typical house, you're looking at 6 to 7 junctions where you have heat loss through thermal bridging. In this particular house here, everywhere where we're showing a purple line, if you want to be serious about addressing your thermal bridging, you should be introducing a thermal block at all those locations where there's a purple line. We have a set of accredited construction details available on our website, which shows how to address those thermal bridges at those junctions. But what we're finding is people who are serious about thermal bridging and they want to deal with all the junctions, they're saying, well, I've blocks here, I've blocks here, I've blocks here. The block layer's not particularly happy because he has to mix and match blocks. The plaster's not particularly happy. So what they're deciding to do is, if they build the entire inner leaf of the cavity wall with a Mannok AIRCRETE block, they're addressing all their thermal bridges by default. They're improving the U value of the wall. They're reducing the heat loss through the thermal bridges by up to 80%. As I say, the U value is improved. If you want, you can pull back on insulation or renewable technologies because you have the benefit of less heat loss through thermal bridging. And when you do your SAP or BER calcs, that will be clear to be seen. No mixing and matching of blocks, so you don't have that issue with the block layer whereby he's mixing and matching blocks. No differential movement between two different types of blocks. Faster response time when compared to dense block. If you come into your house in the evening and it's cold and you switch on your heating, a dense block will take longer, the room will take longer to heat up because the block is absorbing a certain amount of heat, so the room obviously cools up a bit slower. The AIRCRETE block, being a thermal product, doesn't absorb as much heat, so the room will heat up quicker and it will maintain the heat more. Also, they have noted optimal thermal mass. Thermal mass is very important in homes, particularly where you have a lot of south-facing glazing, and that's the way houses are being designed today by good architects. What thermal mass is, I suppose, we can see over in the diagram here, during the day, the energy from the sun is absorbed through south-facing glazing, and that comes in and heats up the room, but the heat then is absorbed by the thermal mass in your room. It's absorbed by your concrete floors and your concrete walls, and what that does is it prevents your room from heating up too much. So it more and then at night, when your room starts to cool down, the heat that's stored in your concrete floors and your walls, it starts to dissipate back into your room and keeps your room warmer for longer in the evening. And what that does, it helps regulate the temperature. So we don't have, your room doesn't get as hot or it doesn't get as cold. It regulates the temperature curve, which is very important. And as I say, we would say that AIRCRETE blocks have an optimal thermal mass over and above dense concrete blocks, which sometimes have that disadvantage of storing too much energy when you're trying to heat up your room from a colder temperature. So we've discussed AIRCRETE inner leaf. If you want to take it one step further, we have been promoting a solution called Sims by Mannok. It's a single leaf block construction with an external insulation system on the outside of it. And you can see an example of both the AIRCRETE inner leaf and the Sim solution on our stand at the show here. So what Sims by Mannok is, it's a unique offering which offers builders in Ireland the opportunity to build a superior performance home in the most cost-effective way. This is the way they build blockwork houses on mainland Europe. Germany, Poland, Austria. There's no cavities in those countries. It's a single leaf AIRCRETE block with external insulation system. And it's combining our Mannok AIRCRETE blocks with a certified external insulation system. I think there's something like 16 certified external insulation systems in Ireland, so there's a wide choice of products there to use. Just looking at it in more detail, 215, so it's a 9-inch Mannok AIRCRETE block. That block is 9 inches wide by 9 inches high, so it's the same size as two 4-inch blocks on the flat. So it is quite quick to build. On the inside, it can be finished with plasterboard or wet plaster. On the outside, you have your EPS insulation, and then it's finished by several coats of render. So you have a base coat. Into the base coat, then you bed a reinforcing mesh, which gives it a strength, and then you have a finished coat on the outside, and that can be a silicone coat, acrylic coat. There's various dash coats that you can put on it as well. Straightforward method of construction. There's no issue with DPCs or anything. The block layers, you're not relying on your block layer to fit your insulation, DPCs, none of that. Your block layer is just laying blocks, and then a specialist comes in and does the external insulation system. The benefits there, we'll run through them briefly here. Some of them's covered in more detail in a few slides' time. Excellent thermal performance, superior fire performance, enhanced air tightness. It's a cost-effective solution, very, very quick, and it's zero condensation risk. So moving on then to look at some of those in more detail. Thermal performance. The structure of the product you're using to build the structure of your house is a thermal product. It's 10 times, the same, more thermally efficient than traditional dense block. So that in itself is giving you a great thermal performance. External insulation is extremely thermally efficient. By wrapping the outside of your home with insulation, and eliminating thermal bridging, that's the best way to insulate your homes. There's no risk of thermal looping, which can be a danger if insulation is fitted incorrectly in a cavity. You're cutting that issue out. There's no reliance on block layers to fit insulation. Block layers get paid typically for laying blocks. And they're not keen on fitting insulation. Some of them do it well, others don't do it so well. So you're taking that responsibility off your block layer. He's there to build blocks, what he's good at, and another specialist is coming then to fit the insulation. There's no restriction on the insulation thickness. I suppose if we're looking at cavity walls now, we're talking about 150mm cavity is typical. If we're looking at a partial fill insulation, we can put 100 to 110mm insulation in that. Full fill insulation could have been 150. With insulation on the outside of a single leaf block work, there's no restriction on the thickness of insulation that you put in there. And if you can see there, 140mm of EPS insulation on the outside of our Mannok block achieves a U value of 0.18, which is quite good. 170mm will bring you down to 0.15, which is sort of passive house level. And if you want to go further, 200mm on the outside of our 215 Mannok block gets you down to 0.13. So your wall is still at sort of that 420mm in thickness, and you have a super low U value there. And then, as I said before, thermal bridging is addressed by almost by default. So you're reducing the thermal bridging at that junction at those junctions by up to 80%. Some people get the impression, because the block is quite late, that it's not strong, that it's not as strong as a dense block. We commissioned a study by a consultant engineer to compare the strength of our single leaf AIRCRETE block built with thin joint mortar against the traditional cavity wall construction. And you can see there a 215 AIRCRETE 7 is up to 300% stronger. So it's 3 times stronger than traditional cavity wall construction. So from a strength point of view, there's no issue at all. In fact, if you wanted to reduce your wall thickness, you could probably get away with a 150 AIRCRETE block, and that reduces the overall thickness of your wall, and you're still stronger here than a traditional cavity wall construction. So from a strength point of view, no issue. Fire performance, the 215 AIRCRETE block gives you 4-hour structural fire performance. If you compare that to timber frame, which typically gets half-hour, it is much more superior than what a timber frame construction is going to get to. The traditional cavity wall gets you 2 hours, which is more than enough, but the single leaf 215 is better than that, and it's a non-combustible material, which is very important. Moving on to speed of build, if we look at the traditional cavity here, we've got, in this particular, if you're to raise your blockworks there by that height, your blockwork, you have 6 blocks to build, and you have insulation installed in your cavity. So that's going to take some time. If you use our Sims solution, your block layer is only building 3 blocks, and he's not, so that's going to be twice as quick already. Then he doesn't have to fit the insulation, so it could be up to 60% quicker to build the Sim solution over and above the traditional cavity wall solution, and it's typically more thermally efficient. So it is up to 60% faster. So from a speed of build point of view, very good. From a cost point of view, when you take your labour into account and the savings you make in time and labour, it is cost comparable with traditional cavity wall construction. And we've done a study to show that it's up to 10 times less expensive than timber frame. And as well as that, if you build your home with either AIRCRETE inner leaf or the Sim solution, we're offering discounts on product bundles whereby you can buy the AIRCRETE blocks, precast concrete floor and roof tiles as part of a bundle, and you will get a 10% discount off that. So some of the guys on the stand can speak to you about that today if it's of interest. So sort of sum up Sims in comparison to timber frame with traditional cavity. Speed of construction, we've talked about it. Sims is very quick. Timber frame is quick also. Traditional cavity tends to be quite slow. Thermal performance, Sims gets excellent thermal performance. Timber frame is good. Traditional cavity, to be honest, is only fair if the insulation is not fitted correctly. If the insulation is fitted well and you deal with your thermal bridging, then it is quite good, but the sim solution has an excellent thermal performance as well. Structural performance, we've discussed that. It stands out in its own in terms of structural performance. Fire performance, 4 hours versus 30 minutes. And cost, we would say that it's best value of all the solutions there. A couple of case studies that was featured recently. This little house in Sandy Cove in Dublin was featured in Passive House Plus a few months ago. It's actually the first house in Ireland to be built to the Passive House Plus standard. So we've quite a few passive houses in Ireland, but this was the first one built to the Passive House Plus standard, and it was built using single leaf Mannok AIRCRETE blocks with an external insulation system. So they used the Sims solution on that particular house, and the estimated energy bill in that house, including charging an electric vehicle, is less than €400 per year. This is another passive house that was built in down in Cork City a few years ago, and it was the first house in Ireland to achieve Gold Standard Home Performance Index. And again, it was built using Sims with a single leaf AIRCRETE block with external insulation. So it's telling that these firsts for Home Performance Index and Passive House Plus standards, that the designers of these houses chose to go with single leaf AIRCRETE and external insulation. Quickly, we're almost finished now. Sustainability obviously is becoming more and more important, and AIRCRETE thermal blocks, as I said before, they're made from up to 80% recycled material, which is very important. That gives them a low carbon footprint, and as well as that, because they're improving the U value of your house and they're reducing thermal bridge, and the overall carbon coming from your home over the lifetime of it is going to be significantly reduced. All our products, including our Mannok AIRCRETE blocks, has a third-party verified environmental performance declaration, so the sustainability credentials of our products can be seen there in our third-party EPDs. AIRCRETE, by its nature, has an A+ green guide rating, which is makes it a sustainable product. And most of the products going into our AIRCRETE blocks are locally sourced, with the exception of aluminium and lime. All the rest of the ingredients that go into those blocks are sourced locally to ourselves, which reduces the carbon footprint for our transport. And because of the weight of the blocks as well, the transport of the blocks to site, you can put twice as many blocks in a load, so again that's reducing the carbon footprint of the transport. Just looking, I suppose, at Mannok as a whole, we have tailor-made packages available. You can discuss them with the guys in the stand today. Some of the other products in our range, we do PIR wall insulation, PIR roof insulation, and we do PIR and expanded polystyrene floor insulation. We also manufacture precast concrete floors and stairs, and we manufacture concrete roof tiles. We've got an excellent technical team who are on hand to discuss your project from early stages, to advise in terms of thermal bridging, U values, etc. I've mentioned the product bundles and the discounts available for buying a combination of products. We've got on-site support services as well, so if you decide to go with the Sims solution and your block layer is not familiar with it, we can send an engineer out to site to help you get started and talk you through the process. The guys in the office there can do estimates of your plans for volumes and U value calculations, etc. So there's a range of incentives there, I suppose, to come and talk to us about your self-build. So that's really our contact details there. There's a self-build brochure available on our stand with those contact details in it. And that's really the end of the presentation, folks. And thanks for your time, but if you have any questions now, I'd be happy to answer them here, or if you're more comfortable, come over and talk to us at the stand. I'll be knocking around there for a while and I can help you out there.